So resuming from where I left off, I'll start with primitives. But before going into primitives, I'll talk about Turing primitives. So see, computers work on binary digits that are zeros and ones, which are basically voltage high and voltage low. Everything we do on a computer can be fundamentally broken down into either 0 or 1. And that is done by the low-level programming languages, which actually convert the human code into the machine language. So to make a computer like that, I need something where I can write my zeros and ones. So that's my Turing machine's tape. Something needs to read the stuff on the tape, 0 or 1, and store it, which is the state register head, which can read, write, and erase these zeros and ones. Then it can move to navigate through the zeros and ones on the tape. So it needs to move left and right. So we have the move left and the move right option. And when the job is done, maybe some program or algorithm is written and finished writing in zeros and ones the binary language, the head needs to stop moving. That's called halt. So these are the 6 Turing primitives, which are actually the most fundamental primitives in any computer. So now let's move on to the primitives in the modern languages. So the most common primitive is the arithmetic operations. So these include the addition operation, the subtraction, multiplication, division, the modulus or the remainder, which is shown by a percentage sign, and the exponentiation or the power, which is in Python represented by 2 stars. Next we can see are the data types. These are again hard-feeded into the language. So the most common data type is the text, which is always used, obviously. So these are called strings in programming. Then are the numbers. So numbers can be of different types like integer numbers, floating point, which are decimals, and the complex numbers from the complex number space. Next are the sequences. So you can store a sequence of data in form of a tuple, list, or range. For mapping the data, you have the dictionaries, at least in the Python language. The Boolean data type, which is basically true and false, is a data type which works on conditionals. So there's a condition given and it sees whether the condition is true or false and it works according to that. Next is a set. So in Python, there are set and frozen set, 2 data types in the set category. Then comes the binary, which has bytes, byte array, memory view, and more. And final is the none. So there's one none type. So these are the data types in the modern languages, specifically Python. The next primitive I can move on to is control structures, which are mainly used. There are 3. So one is if-else. Second are the loops, like the for loops, while loops, and the do-while loops. And third is the function or the method calls. So these are the 3 basic control structures in Python language. Moving on to the fourth, there are input-output operations. There are functions for reading input from the user or from external sources like files and outputting data to the screen like the monitor. You can print something, so that's output. And you can, let's say, read a txt file, .txt file, so that's input for you. Then there are collections. So there are primitives for creating and manipulating data collections, which are called arrays like list, there are dictionaries, and there are sets. So these are the primitives for collections of data. Then we have operators like the comparison operator, bitwise, logical, arithmetic, and many more. The 7th primitives is gonna be string manipulation. So there are many ways to manipulate a string. So there's one concatenation where you actually sum up 2 strings or you merge 2 strings together. Second is a substring extraction or indexing. So each and every alphabet in a string can be indexed. So that's substring extraction. And then there's character manipulation. I'll be covering all of these in the practical coding part, but not now. Then there are primitives for memory management. There are primitives for error handling. And there are primitives for file operations for, let's say, opening a file, reading, writing, and closing the files from the computer. So basically, the programming language can interact with the computer, and there are primitives for that inbuilt into the language. And the most crazy part about this is anything computable in one language is computable in any other language. So basically, all languages can perform the operations of each other. This is very possible because any code if written in one language can be actually translated into some other language, and the logic would still remain the same. Now, this is a technical term called code blocks, which is actually pretty simple, but it seems very complex. Like, what are code blocks? So code blocks are basically parts of code or segments of code separated by in Python an indent or a space. Code blocks are basically group of codes. So these were the code blocks. Then I can move on to the aspects of language, but I'll not be covering it right now. I'll be covering it in my next video. So, so wait for the episode 3 to come and tell me in the comments if I can actually explain these things well. Am I myself lacking the understanding of these topics? I would have to know because I don't care about subscribers and all. I just want to know if I myself understand these topics and if I really do understand it so well that I can explain it to you very simply. So tell me down below and I'll see you in the next video. Bye.